Great job on your homework. You can go ahead and put that away and go and take out your books, but leave them closed for just a few minutes before we jump into our lesson. I have a few questions for you, and let's see how much we remember about solving our equations, because that's exactly what we're going to be doing today. We're going to be looking at some new equations and learning how to solve some of them. So when we have an equation, so anything that is set equal to something and we're trying to solve, what is our first step in solving an equation, Joy? She said simplifying or identifying the unknown, and sometimes those can be done together. That's a great answer. We always want to simplify to get things as simple as possible to make sure that we don't have any extra work when we get down later in our problem. So we identify the unknown and then we are simplifying, and the next step is one that it kind of has a little ring to it. What is the next step when we're solving our equations, Maya? That's right, it is to get the unknown alone. And we get the unknown alone by doing opposites. Why does doing the opposite to an operation help us get the unknown alone, Mark? That's exactly right. And can you give us an example of what an opposite would be? So if we had -3, you would add 3 and it would give us 0. That's right. That's a great example Mark gave, and we've seen that over and over. Whenever we do the opposite of something, it cancels them out. And why must we do the same thing to each side, Jobin? So that we can keep our equation the same. We're not changing the problem at all. We're just canceling out things and making sure they're equal and balanced all the way down. That is a great answer, and that's exactly right. We have those handy rules that we've been using. Get the unknown alone by doing opposites. Whatever you do to one side, you must do to the other. And then, of course, we always check our work. But sometimes, maybe you get a problem, maybe it's not always in math, and you get a problem, and you find an issue, and then when you find that problem, it leads to more problems. I remember when I was a kid, and I used to love to go fishing with my dad, and we had a little boat that we would take out every summer to the lake, and we would go fishing, and sometimes we would notice some of our things were getting wet, and then those things would get ruined. Well, then we would hang them out to dry because we didn't want them to be ruined, or we didn't want them to be wet whenever we were going to use them. But then when we would go back out, it would happen again. Well, we were only fixing part of the problem. What we needed to fix was maybe a few cracks in our boat. We have problems like that in algebra too. Sometimes we have one big thing, and if we take care of it and we get rid of it, then it fixes everything else and it makes our lives a whole lot easier. And we're going to be talking about that today. You can go ahead and open your books to page 136, and we're going to be looking at fractions in equations. And I know not all of you are very fond of fractions. Sometimes I'm not either. Sometimes they make it a little hard to work with or a little more difficult. So it'd be nice if we could just clear our whole equation of the fraction, right? And then we would know how to work through it just like we've been working through our equations the past few days. So everybody look up here at the board with me. We have 2/3 x equals 12. And we have this really big fraction, and it's not really big, but it's just this fraction that's kind of taking over the whole problem. It's kind of clouding it. It's not a nice problem. And we want to get rid of this fraction. Is there a way that we can just get rid of the fraction? Well, there is. We don't have to work with it and multiply and then divide. We can do everything at the same time. We have heard this term before, and it's called a reciprocal. I want to refresh your memory on what a reciprocal is. That is the inversion of a fraction. So basically, whatever the fraction is flipped around. So if I had 4/3, well, the reciprocal of this would be 3/4. You can see it's just the fraction that has been inverted. We can do that with anything. If I had 7/8, what would the reciprocal of 7/8 be, Maya? 8/7. That's right. So go ahead and look back over here at this problem. Now that we've gotten down what a reciprocal is, we have 2/3 x equals 12. And the first thing we want to do in our equation is to simplify. And I'm looking at our problem, and everything is simplified. This isn't anything we can reduce or we can simplify. It's as simple as it's going to get. So I have my unknown, which is x, and I need to get it alone. And if you remember, I said we want to get the unknown alone by doing opposites. So we're going to use a reciprocal, or we're going to use the opposite, just like we have been doing, to get this alone and clear the whole fraction of the entire equation. So I want to use the reciprocal of 2/3. I'm going to multiply 2/3 on this side, the reciprocal of 2/3, which is 3 halves. Everybody agrees with me that the reciprocal of 2/3 is 3 halves. But remember, whatever you do to one side, you have to do to the other side. So I'm going to come over here to 12, and I'm also going to multiply it by 3 halves. Not 3/12, 3 halves. So everything's the same. I put this up here, and I made it a little uneven while I put this over here, and now our equation is the same. I haven't changed anything because it's on both sides. So now I'm just going to do our order of operations. We're going to cancel right here our 3 halves times 2/3. That's just the multiplication of fractions. And we know that we can cancel. This 3 will cancel the 3, and the 2 will cancel the 2. But look at there, it leaves us with 1. So we have x. We don't need to write the 1 because we know it's understood. Then I'm going to come over here, and I'm going to do the same thing. If this helps you, we can put a little 1 there so we can see how we're canceling. 2 goes into 6. 2 goes into 12. 6 times, I got a little ahead of myself there, to give us 6 times 3. So we got that x equals 18. Now, there was another way we could have done this, and we would have solved this if we were doing this the other way. We would have solved it like this. Well, first we would have multiplied 3 to each side, and we would have gotten 2x equals 36, and then we would have divided by 2 to get 18. So you can see I saved myself a few steps by clearing the fraction first. So we got the answer 18, and let's go ahead and make sure that we did I did my arithmetic right, and we got it done, so we're going to check. So now I'm going to take my original equation, 2/3 x is equal to 12. Make sure you're paying attention, your eyes are up here, Joy. And we're going to just plug in 18 over in for the x. So we have 2/3 times 18 is equal to 12. Well, we can do our cancellations and get 6, and we know 2 times 6 is equal to 12. So you can see how just a simple reciprocal being multiplied to both sides of our equation makes our work a whole lot more simple and a lot easier. So let's go ahead and look at this one. 5 6x equals 10. Once again, we have a fraction, and we want to get rid of it. We want to just go through the whole equation and get it to where we have no fraction. So if we're going to use a reciprocal, job in what reciprocal would we be using? 6/5. That's exactly right. So we are just going to invert that and get 6/5. And so I'm good to go to just multiply through. Okay, I see some of you, y'all are staying alert. Great job, class. We need to do it to both sides. That's exactly right. So we're going to come over here and multiply the fraction 6/5. 6/5 to both sides. And now we're just going to cancel through. So we'll cancel this 5 and this 5. Isn't that so nice how everything just kind of drops away once we can cancel out? So you end up with x equals, and we're going to go ahead and do our operation on that side. So what can I do here, Maya? All right, she says cancel to get 2, and we know that 2 times 6, class, 12. That's exactly right. So we got x equals 12. And we all did that in basically one step. We didn't have several lines of work, and that'll come in handy when we have bigger fractions and longer fractions, and more than one fraction in an equation. So we had x equals 12. We'll go ahead and check our work. How do we check our equations with the answer that we've gotten, Joy? She says plug in 12 for the x. So that's exactly what we're going to do. And let's see what we get. Mark, what do we do with our 5, 6 times 12? Okay, he said cancel. And so that gives us 10 equals 10. We did our problem correct. Great job. So we see that flipping flipping our fraction makes it nice and simple for us to do. Let's go ahead and do this one together, and then we'll have some for you to work on at your desk. So 1/6x equals 3. once again, we have a fraction. And this is not a very big fraction, it's just 1/6, easy to work with, but we're still going to go ahead and use our reciprocal to clear this fraction of the equation, to clear this equation of our fraction so we can have easy solving. So Maya, what is our reciprocal? What do we want to use? 6/1, and she noted that we want to do it to both sides. Great job, Maya. So now we're just going to cancel, and it floats down to the bottom, and we get x equals 18. Let's go ahead and check it. We'll get 1/6 times 18 equals 3. And 6 cancels. 6 goes into 18 3 times, so 3 equals 3. Great job. Y'all are catching on pretty well. Go ahead and look at what I have up here on the board. 1/6x equals 7. And go ahead and take out some paper or write it there in your book. It's actually number 1 in your book. So go ahead, I'm sorry, it's number 2. So go ahead and work that out on page 137. Okay, don't forget to check it. Looks like y'all are finishing up. Just a few more. Once you're finished, go ahead and put your pencils down and look up here at the problem where it is on the board. Okay, everybody's finished. So we're just going to go around the room and I'm going to ask you what steps you took, and we're going to write them up here and see if we come to everybody has the same answer. So we'll start with you, Mark. What did you do first in trying to solve this problem? You looked to simplify, there was nothing there, so you multiplied by the reciprocal of 6/1. This one's very similar to the one we did over here. And he multiplied it to both sides. And then what did you do, Jobin? This is what you ended up with, and you canceled to get x equals 42. That's what my paper looked like. We'll go ahead and check it. Maya, how did you check it? You said 1/6 times 42 is equal to 7. Joy, we're back to you. What did you do? You canceled to give us 7 equals 7. And that checks out perfectly. Go ahead and do numbers 3 and 4 in your books. Be working on those. Make sure you check them, and then we'll get a few of you at the board. Okay, Mark, if you will put yours, number 3, on the board, and then Joy, you will be putting number 4, and by the time they get that written, everyone should be finished up with those. Okay, Mark and Joy have their answers written on the board and their problems. So Mark, go ahead and show us number 3 and tell us why you did what you did. So Mark ended up with x equals 12. That looks great, class. Do you agree? All right, y'all's work lined up. Great job, Mark. You can erase that and have a seat. And then Joy, number 4. You had some fractions there to deal with. Go ahead and show us what you did. And she checked it. X equals 15 halves. So that one, we didn't get a whole number like we have been. Great job on making sure you did your arithmetic right, Joy. That is great. You can have a seat. And make sure you erase the board, and then you can have a seat. So all the ones we've been clearing, fractions, our equations, they've all just had one fraction. But we know that sometimes we're going to have more than one term. We're going to have more than one fraction on a side of an equation, or even throughout the whole thing. We might have something that looks like this. We have 1/2 x plus 1/5 x equals 14 up here on the board. So we could multiply by the reciprocal, but then we'll drop out x. So if we just multiply this by 2 over 1, it would then drop x, but we would still have 1/5 x. And so we still have a fraction. There's still stuff we want to work with. So whenever we have more than one fraction in an equation, we are going to look to find the lowest common denominator among both of our fractions. So let's look at 1/2 and 1/5. And we want to know what the lowest common denominator is. We have had lessons where we went over and we did the greatest common factor, least common multiple, greatest common denominator, least common denominator, all of those things. So that's what we're going to be using today, is our least common denominator. So we can look at 1/2 and 1/5, and some of your wheels are already turning. I want to find something with the least common denominator that is common among them. And we know that 2 and 5, we're thinking, okay, we know that 10, because 2 times 5 equals 10. So we can use 10. If you ever can't find it, you can just multiply the two numbers together to get your answer. That's what I did here. I said 2 times 5 equals 10, and we know that both of those numbers will go into 10. So what I'm going to do is you're going to multiply the entire equation by the least common denominator. And our least common denominator that I said was 10. So we have 10 now, and we're multiplying it to the whole thing. Now there's two different ways that we can write this. And the first way we're going to do it is putting the whole equation in parentheses. That's how I like to do it, but you might like to do it the other way. So we'll have a little bit of options for how we like to multiply our entire equation. That's right. Both ways we're going to be multiplying the entire equation by the least common denominator, which I came up with 10. So now I'm just going to multiply this to every single term that is in our equation. So 10, right here, 2 will go into 10, and it cancels to give me 5. And 5 will go into 10, which cancels to give me 2. So now I have 5x plus 2x equals, and I can go over here, and 10 times 14 is 140, because we are just adding a 0 since we're multiplying by 10. So now this is much easier to work with. Now we can simplify, get our unknown unknowns, and we can solve no problem because we don't have these fractions. We could have solved it with the fractions, but it was going to be a lot more work. So we know 5 times 2, 5 plus 2, 5x plus 2x equals 7x equals to 140. I can go ahead and get my unknown unknown by doing opposites. So I'm going to divide by 7, and x will give us 20. That is our answer, and we can check it. We can start with our original. 1/2 times 20 plus 1/5 times 20 is equal to 14. Notice I didn't bring 140 down, I just brought 14 down. So we have 2 goes into 20 10 times. 5 will cancel and give me 4, plus 4 is equal to 14. So 14 is equal to 14. I know that's getting a little low on the board, but 10 plus 4 is equal to 14. So it's nice and simple. We just find the least common denominator and multiply the entire equation. So our final answer here was 20. Now let's look over here. We have 2/3 x equals 1/2. And this one looks shorter, but we still have 2 fractions, and we still need to find our least common denominator and multiply it to both sides of our equation. So we're looking up here for our least common denominator, and it's not going to be 4. Jobin, is it going to be 4? No. Maya, it's going to be 6. That's right. So Maya raising her hand. She knows that it's going to be 6. So over here, we did it in big parentheses. I'm going to show you another way that you can write it if you want to. So we're going to be multiplying the whole thing by 6 because that's our least common denominator. So I could do 6 times 2/3 x plus, oh, not plus, that should be equals 1/2 times 6. So you can see if you compare how we multiplied, I did the same thing over here and I did the same thing over here. I just only wrote my fraction or my least common denominator one time. So we're going to go ahead and solve this. What can we do right here to get this solved? Joy, she says cancel. So we can have 4x is equal to 1/2 times 6. And these will cancel. And what does that give me, Mark? 3. So we should get x equals 3/4. Let's go ahead and check it. How do I want to check this, Jobin? Plug it back in. So I just have 1x, so I'm going to go 2/3 times 3/4 is equal to 1/2. We can cancel. We'll have 2/4, which is equal to 1/2. That does not match. What did we do wrong? Joy, do you see anything we did wrong? That's right, we didn't reduce. That's why it's always important that we reduce to the lowest term. So we are going to get 1/2 is equal to 1/2. So it's important that we're paying attention to all of those fractions. Go ahead and look in your books at number 7 and work that one in your book, and then we'll do it on the board together in just a moment. Yes, Maya, let me get a tissue. You're working diligently. Check your work when you get your answer. Mark, make sure your feet are on the floor. Okay, so everybody looking up here, looks like y'all finished it up and you've checked your answers. So we have 1/2 x plus 1/4 x equals 12. And once again, we have more than one equation. Jobin, what did you do to get this one started? You found the least common denominator to be 8. You found it to be 8. Does everybody agree with it being 8? It is 8 would work, but I don't know that it's our least common denominator. Joy, what did you get? So you used 4. That's a great observation, and we're going to use 4 for this one. Jobin, go ahead and follow along on your paper, even though you had 8, and let's see if we came to the same answer. So you used 4, and we're going to multiply it by the whole thing. So Mark, what did your next line look like? What did you have? So you had this, and that cancels to give us 1, and this gives us 48. Okay, so you had 2x plus x equals 48, which gives us 3x equals 48. And then Maya, what did you get for our 3x? You said you want to divide by 3, so that would give us x equals 16. Okay, class, did everybody have x equals 16? I agree with that. And Jobin, you used 8, and did you get x equals 16? You did, that's right. So even if we don't use the exact least common denominator, well, there's only one least common denominator, but if you don't use the lowest, but you still use one that will cancel, you can see that we can get the same answer. So we're not going to check that one for sake of time, but you'll be practicing those tonight in your homework, looking for the least common denominator and then applying it to everything. Well, we've used fractions, and there's one other thing that we need to look at when we have equations that can make our equations a little bit difficult at times. Maybe we'll have a problem like this. 0.8x equals 2.4. I don't know about y'all, but I don't like using decimals almost as much as I don't like using fractions. Decimals just kind of make me a little nervous sometimes, making sure I keep them lined up, and my multiplication, I might forget to move them over. So it would be nice if we could just knock this whole equation out of our decimals, so we don't have to use them to divide by decimals or multiply. And we can somewhat do the same thing as we did with fractions. Let's come over here and take a break from this problem for just a second. We're going to look at something. Remember, we had our scale and our tens places. We have the tens, the thousands, the hundreds, and we can go through, and we know we're moving our decimals over in order to give us a number that is different, but it's still proportional. So what if we had 0.21? And we know that 0.21 is less than 0, right? Well, what if we wanted to make it a whole number? Remember, we would just move our decimal over 2 places, which would really be, what is 2 places? What number do we have that has 2 zeros that represents our 2 places? It's 100, right? So we know that 0.21 times 100 would actually give us 21, and then we don't have a fraction anymore. Not a fraction, we don't have a decimal anymore. Or maybe we have 3.4. Well, how many places are represented that need to be moved over, we need to get rid of? 1, that's right. So what would we multiply it by if it's just one place? What represents the 1's place? The 10, that's right. So we would multiply this by 10 to give us 34. So we've worked with moving over our decimals. That's nothing new to us. So we can go ahead and apply that to our problem today. So we'll look over here at 0.8x equals 2.4. And we need to get rid of this. We need to multiply it by some power of 10, some form, so that we don't have decimals anymore. So I'm going to multiply it by 10 because right here on my x side I only have 1 decimal. So I'm going to multiply 0.8x times 10, but if I do this and don't do it to the other side, my equation isn't very balanced at all. It's not even, it's not equal, so we have to keep it the same going down. So I'm going to multiply 2.4 times 10 also. So now I'm just going to move my decimal place over to get 8x, and then here I would move it over 1 to get 24. Well, that's simple math. From here, simple of solving our equation, we're going to get our unknown alone by doing the opposite to both sides. So we would get x equals 3. Well, let's go ahead and plug it in and see what we get. 0.8 times 3 equals 2.4. Well, if you're not sure about your decimals, we can always do our long form of, and we're going to get 8 times 3 is 24. Moving over our decimal, make sure we put it in, is equal to 2.4. So there you have it. We can just move our decimals over however many places as long as you multiply it by that power of 10 to both sides. Let's go ahead and do one more problem of these, and then we will get our homework. Let's look at 0.3x. This one is in your book. I think it's number 12. 0.3x is equal to 21. Once again, we have this decimal, and it's just trying to divide 21 by 0.3x. That's not going to work out for us. So what should we do, Jobin? Move the decimal over. That's right. And how many times should we move it over, Joy? 1. That's right. So we're going to move this over. We're going to multiply it by 10. We can't just move it over without multiplying by something. We don't have that power. So make sure you're always multiplying it by something. You can't just move the decimal because you want to. That would be nice if we could, but that's not how our math works. So we're going to multiply both sides by 10. So we should get 3x is equal to 210. And then we can divide to get x equals 70. And we know that's right. If we plug it back in, 0.3 times 70 is equal to 21. That is great work. You'll be practicing with these decimals today. Remember, we just have to multiply it by some power of 10 in order to move our decimal over. You can go ahead and take your homework notebooks out. We're going to be doing sharpening skills 2 through 20, even on page 139. You're dismissed.